Ever wondered if our universe is just one in a series of many? This isn't a premise from a science fiction novel, but a genuine question pondered by some of the greatest minds in cosmology. One such mind is that of the esteemed British mathematician, Roger Penrose. His contributions to the world of mathematics and physics have been instrumental in shaping our understanding of the universe. Born in the heart of Essex in the early 1930s, Penrose spent his early years immersed in a world of numbers and equations, developing a fondness for the complex and the abstract. As he delved deeper into the mysteries of the cosmos, Penrose introduced a unique view of the universe in the 1960s. He proposed a theory that was as fascinating as it was radical, the idea of a cyclical universe. This concept suggests that our universe is merely one cycle or eon in an endless sequence of cosmic birth, evolution, and demise. This is not a simple case of history repeating itself, though. Each cycle, according to Penrose, begins with a Big Bang, a massive explosion that gives birth to a new universe. As this universe evolves, it eventually meets its end in a big freeze or big crunch, marking the start of a new cycle. This groundbreaking theory, known as the conformal cyclic cosmology hypothesis, posits that the universe we inhabit is not unique. Instead, it's part of an eternal succession of universes, each following the other forever. The implications of such a theory are profound, challenging our understanding of time, space, and existence itself. It's a concept that continues to intrigue and baffle scientists and laymen alike, prompting us to question the very nature of our reality. Hold tight, as we are about to delve into the fascinating world of Roger Penrose's theories. In the 1960s, Penrose started to challenge the common perceptions about the universe. As a young mathematician, he was never one to shy away from the extraordinary and unexplored territories of cosmology. His mind was a playground of ideas, where he dared to dream and theorize beyond the conventional understanding of space and time. One of his most profound theories was the idea of a cyclical universe. While most of us grew up believing that the universe had a singular birth through the Big Bang, Penrose suggested something different. He proposed that the universe is not a one-time phenomenon, but rather undergoes continuous cycles of birth, evolution, and death. Imagine the universe as an eternal phoenix, constantly reborn from its own ashes. Each cycle, or as Penrose called it, eon, begins with a Big Bang, a moment of unimaginable heat and density. This is followed by a period of expansion and evolution, where galaxies form, stars ignite, and planets take shape. Life as we know it unfolds. But this is not a never-ending story. Each eon eventually reaches its end, not in a dramatic cataclysm, but in a slow, cold, big freeze, or a gravitational collapse known as the Big Crunch. In the 1960s, this was a radical departure from mainstream cosmology. It was an idea that shook the very foundations of our understanding of the universe. It was not just a theory about the birth and death of stars and galaxies, but a theory about the cyclic nature of existence itself. To think that our universe is but one chapter in an unending cosmic saga was, and still is, a mind-bending concept. Despite the revolutionary nature of these theories, Penrose was not deterred by skepticism or disbelief. He was driven by a desire to understand the universe in its entirety, from its smallest particles to its largest structures, from its birth to its death. And this was just the beginning. But Penrose didn't stop there. His theories continued to evolve and expand. The groundwork he laid down in the 1960s would pave the way for even more groundbreaking theories, forever changing how we perceive our universe. Imagine a universe born from a Big Bang, evolving and eventually ending in a catastrophic collapse. Now, let's dive into the crux of Penrose's theories, which revolve around these two cosmic phenomena, the Big Bang and the Big Crunch. According to Penrose, these events mark the beginning and the end of each universe cycle. Let's start with the Big Bang. Picture an incredibly dense, hot singularity, sprouting into existence and exploding to create everything we know as the universe. From galaxies and stars to the smallest atoms, all sprang from this one momentous event. This is the birth of a universe, or an eon, as Penrose calls it. Over billions of years, this universe evolves. Stars form and die, galaxies collide and merge, and the universe expands. This expansion is a crucial part of Penrose's theory, as it sets the stage for the universe's inevitable end, which brings us to the Big Crunch. After an unimaginable amount of time, the universe's expansion slows, stops, and then reverses. Everything that once spread out starts to pull back together. Galaxies, stars, even black holes all merge back into a single point. This is the Big Crunch, the end of an eon. But here's where Penrose's theory deviates from traditional cosmology. In most theories, the Big Crunch is the ultimate end, the final curtain call. But not for Penrose. For him, the Big Crunch is not the end, but a transition, a bridge between one universe and the next. In the cyclic view of the universe, each Big Crunch leads to another Big Bang, giving birth to a new universe. And so, the cycle repeats over and over again, in a never-ending sequence of birth, evolution, and death. But what happens after the Big Crunch? Penrose had some ideas about that too, and we'll delve into those ideas in our next segment. Welcome to the world of conformal cyclic cosmology, Penrose's groundbreaking hypothesis. This theory catapults us into a realm where the universe isn't a one-time event, but an endless cycle of beginnings and endings. The conformal cyclic cosmology, or CCC, is a bold departure from the standard cosmological model. It proposes that the universe isn't unique, but rather one in an eternal succession of universes, each termed an eon. These eons aren't just sequential, they're cyclical, taking us on a cosmic merry-go-round that spins forever. Here's how it works. Each cycle, or eon, begins with a Big Bang, the explosive birth of a universe. This universe evolves, stars form, galaxies cluster, and life might even emerge. But as the eon ages, it expands, cools, and eventually freezes in what's known as the Big Freeze. But it's not the end. Instead, according to Penrose, this Big Freeze is just the setup for another Big Bang. The universe, now cold and empty, loses its sense of scale. Without mass to give it meaning, space and time become meaningless too. In this state, a new Big Bang can occur, birthing a new universe, a new eon, and the cycle continues. This hypothesis has profound implications for our understanding of the universe. It suggests a cosmos that's infinitely old and infinitely large, a universe that's not a standalone event, but a link in an eternal chain of cosmic life and death. Yet, the CCC is not without its challenges. Critics point to a lack of empirical evidence and the difficulty of testing such a theory. But Penrose is undeterred. For him, the beauty of the CCC lies not in its proof, but in its potential, the possibility of a universe reborn in an endless cycle of creation and destruction. So, are we living in just one of an infinite series of universes? According to Penrose, the answer is yes. Penrose's theories have not only challenged our understanding of the universe, but also inspired further scientific exploration. His groundbreaking ideas have sparked a shift in cosmological thought, prompting us to question our perceptions of the universe's existence. Let's revisit the key points about Penrose's theories. He proposed the idea of a cyclical universe, a concept that shakes the very foundations of traditional cosmological thought. This revolutionary theory, known as conformal cyclic cosmology, posits that the universe undergoes continuous cycles of birth, evolution, and death. Each cycle, or eon, begins with a Big Bang and ends in a Big Freeze or Big Crunch. But why are these theories significant? For one, they challenge the widely accepted belief in a single, linear progression of the universe from the Big Bang to the present day. They encourage us to view the universe not as a singular entity with a fixed beginning and end, but as a dynamic, ever-evolving cycle of life and death. Moreover, Penrose's theories have profoundly influenced other scientists and researchers. His ideas have formed the basis for numerous studies, contributing to our expanding knowledge of the universe. They have fostered a culture of inquiry, inspiring scientists to delve deeper into the mysteries of our cosmos. Yet, as with any groundbreaking concept, Penrose's theories have sparked ongoing debates and discussions. Some scientists question the validity of his ideas, while others seek to build upon them. These debates are crucial to scientific progress, driving us to continually question, test, and refine our understanding of the universe. In conclusion, the significance of Penrose's theories lies not just in their innovative nature, but also in their ability to inspire curiosity and drive scientific exploration. The universe, according to Penrose, is an endlessly fascinating, endlessly evolving entity, and as we continue to explore its mysteries, who knows what we might discover next?